Hello, and welcome to homework 6.03. This is all about parallel and perpendicular lines. All right, so let's see what we have here. Number 1 says, find the slope of a line parallel to the graph of each equation. So what we have to remember here is that when lines are parallel, they have the same slope. All right, so these are questions kids tend to try to make more challenging than they actually are. All right, if the slope of this line is negative 2/3, the slope of a parallel line is just going to be negative 2/3. It's going to be exactly the same because parallel lines have the same slope. And the reason I knew it was negative 2/3 is because it was the number in front of the x. Whatever's next to the x is always your slope. So if we go over here, you might be saying to yourself, but on this one there is no number next to the x. You just have to remember that there's that invisible 1 there. So if the slope of this line is 1, the slope of a parallel line would also just be 1. All right, so parallel lines have the same slope. Number 2 says, find the slope of a line perpendicular to the graph of each equation. All right, now perpendiculars a little different. Perpendicular slopes are what we call negative reciprocals, which is just a fancy way of saying our flip that we've talked about in class, where you have to flip the sign and you have to flip the fraction. Okay, so if I look at this first problem here, this slope is negative 3. Now, if I want to turn negative 3 into a fraction, it would just be negative 3 over 1. So when I flip negative 3 over 1, the starting fraction was negative, so our new fraction is going to be positive, and the starting fraction was 3 over 1, so our new fraction is going to be 1 over 3. So we went from negative to positive, that was the first flip, and then we went from 3 over 1 to 1 over 3. That was the second flip. Right? Now, if we look at the second one here, there's going to be a little more work that we have to do because we don't know the slope of this equation yet. To know the slope of the equation, we have to start by solving for y. So let's subtract 2x from both sides. All right, those will cancel out. We'll have 3y equals 5 minus 2x, and then we'll divide everything by 3. And we'll get y equals 5/3 minus 2/3 x. Okay, so there's our equation. The negative 2/3 is our slope because it's next to the x. Now, if we're going to do a perpendicular slope, we have to flip. So it goes from being a negative to a positive, and it goes from being 2 over 3 to 3 over 2. So there's our second perpendicular slope, and then over here was our first perpendicular slope. Okay. All right, let's look at kind of the writing equations of lines problems now. So number 3 says, write the equation of a line parallel to 2y minus x equals negative 12 that also passes through the point 8, negative 5. Okay. So, same kind of process as before. Step 1 is we need an m, we need an x1, and we need a y1. And what you're going to see is the only thing that ever really changes is how we find this m. Everything else is going to kind of follow the same procedure we've seen for the last few classes now. So our x1 is going to be the 8 over here because the x always comes first. The y always comes second. So our x1 is going to be 8. Our y1 is going to be negative 5. Now our m, we're going to find our m based on what we know about parallel lines, which is that they have the same slope. So when we find the slope of this line, that will give us the slope that we can use for this new line that we're going to be creating. Okay, so we have to find the slope of this line, and then we can use that slope over here to create our new line. So to find this slope for 2y minus x equals negative 12, we're going to have to solve for y. So 2y minus x equals negative 12. I'm going to start by adding x to both sides. So that's going to be 2y equals negative 12 plus x. And then I'm going to divide everything by 2. Okay, so this will be y equals negative 6. And then you just have to remember that in front of that x is that 1 that we don't really write. So it's going to be negative 6 plus 1/2 x. Okay, so again, looking at these two numbers, I know the 1/2 is my slope because it's next to the x. And since the lines are parallel, if this has a slope of 1/2, then my new line will also have a slope of 1/2. Okay, so now I have my 3 pieces of information, and now we're kind of back to where we were last homework. It's just going to be y minus y1 equals m times x minus x1. We're going to plug in our information. So y minus a negative 5, which we're not going to leave, that's going to become y plus 5, equals 1/2 x minus 8. Okay. Now that was step 3. Step 4 is to solve for y. So we'll distribute. We'll get y plus 5 equals 1/2 x minus 4. And then we'll subtract 5 from both sides and get y equals 1/2 x minus 9. Okay. And again, like we said, it's really easy to sort of check these problems. So you can always take out your calculator, go to your y equals menu, and then if we type in 1/2 x minus 9, and then go to our table, hopefully we're going to find that point 8, negative 5 that was supposed to be part of our line. And yep, there it is, 8, negative 5. So that gives us the confidence that we got this one right. Okay. Let's move on to number 4. Write the equation of a line perpendicular to y equals 3/4 x plus 1 that also passes through the point 6, 8. So perpendicular is where we have to remember flip, flip. We're going to flip the sign, and we're going to flip the fraction. So on this one, it's kind of nice because the y is already by itself. So if we look at these two numbers, we know that the positive 3/4 is our slope because it's next to the x. So the positive 3/4 is going to flip, flip into a negative, positive to negative, 4/3. So the sign flipped and the fraction flipped. And now that I have that, I can get going here. So my m is going to be negative 4/3 because it's perpendicular to this line right here. My x1 is going to be 6. My y1 is going to be 8. And I'm just getting those from those points right there. And now I just plug those into my formula. So we've got y minus y1 equals m times x minus x1. And then let's plug the pieces in. So y minus 8 equals negative 4/3 times x minus 6. All right, that was step 3. And then step 4 is to solve for y. Okay. Again, don't let the fractions kind of intimidate you here. If you've got negative 4/3 times negative 6, you can just type it in here, negative 4/3 times negative 6, and you're going to see that ends up just being a positive 8. Okay, so we've got y minus 8 equals negative 4/3 x plus 8, because we had that negative times a negative. And then over here, our last step will be just to add 8 to both sides. And we get y equals negative 4/3 x plus 16. Okay. And again, because it doesn't really take that long, there's no reason not to do it. Just go here, go to your y equals, we've got negative 4/3 x plus 16. We'll go to second graph, and hopefully we're going to find that point 6, 8, and look at that, it's right there at the top, 6, 8. So that tells us that we did the rest of the problem right. Okay. All right, let's take a look at what we have to do on the back. All right, on the back it says determine whether each of the following pairs of equations are parallel, perpendicular, or neither. First, put the equations into slope-intercept form. All right, so that's just saying solve for y, because without solving for y, you don't know the slopes. So what we have to remember is parallel lines have the same slope. So if we look at the two equations and they have the same slope, that tells us they're parallel. Perpendicular lines have flip-flip slopes, or negative reciprocals, which means we're flipping the sign and flipping the fraction. Or neither is just everything else. So if one of these two aren't true, then it's going to be neither. So let's take a look at this first one. All right, so you can kind of think about this as this is equation 1, this is equation 2. So the slope of equation 1 is a positive 2/3. All right, and I just like writing the positive sign in because I feel like when we're looking at did you flip the sign, did you flip the fraction, it's just easier if you have the visual of the positive sign. All right, and then if we do M2, that's going to be this 3/2 that's in front of the x, and again, that's a positive 3/2. All right, so if we look at these fractions, they're clearly not the same, so it can't be parallel. Now, a lot of times kids want to say, oh, perpendicular because the fraction's flipped, but if we look at the signs, and this is why I like writing them in, is those are two positive signs, which means the sign wasn't flipped, so this cannot count as perpendicular. This would be a neither because the signs are not flipped. Okay, now if we look at B here, the problem that we're going to run in with B is that in both of these the y is not by itself, so we're going to have to do a little work here. So let's start with equation 1. 5y equals negative 3x minus 9. So we got to get the y by itself. Divide by 5, divide by 5, divide by 5. Y equals negative 3/5 x minus 9/5. Okay? So again, I've got these two numbers here, but I know this one is my slope because it's next to the x. So here my m is negative 3/5. All right, now let's take a look at equation 2. All right, equation 2 is 3y minus 5x equals 24. All right, so let's see what we got here. We're going to add 5x to both sides. We're going to get 3y equals 24 plus 5x. We're going to divide everything by 3. And we're going to get y equals 8 plus 5/3 x. So our m here is a positive 5/3. All right, so now let's compare the two slopes that we have. This one is negative, this one is positive, so that flipped. This one is 3/5, this one is 5/3, so that also flipped. When both pieces flip, that is perpendicular. All right, let's take a look at C here. Now C is a little different because those aren't like equations like we're used to seeing. There's no like clear y-intercept, there's no clear slope. So let's actually do this one a little different. So what I'm going to do is I'm going to just make a little XY grid quickly. All right, so there's my x-axis, there's my y-axis. So if I wanted to graph x equals 2, I would go to where x is 2, so that means over to the right here, and then my line would just be straight up and down. All right, so this would be x equals 2. if I wanted to do y equals 9, I would just go up to where y is 9, so that would be way up here, and then my line would be straight across like this. So that would be y equals 9. And what you're going to see here is that these two lines are actually perpendicular because they make a right angle. So these are going to be perpendicular. All right, so this one's a little different because it's not like solving for y and like comparing the slopes, but if we make the graphs, we can see that these two are going to be perpendicular. All right, so let's take a look at the last one here. So D is 3x minus 5y equals 3, negative 5x plus 3y equals 8. So this is going to be another one where we have to solve for y. So let's start with equation 1. 3x minus 5y equals 3. So I need to move this 3x over, so I'm going to subtract 3x. Negative 5y equals 3 minus 3x. I'm going to divide by negative 5, divide by negative 5, divide by negative 5. And we'll get y equals negative 3/5. And then here we have a negative divided by a negative, so that's going to become a positive 3/5 x. All right, so the slope for this equation is just m equals, and then I take the number next to the x, 3/5. All right, let's take a look at the second equation. Negative 5x plus 3y equals 8. All right, so I've got to move the x over again. This time I'm going to add 5x to both sides. So now I've got 3y equals 8 plus 5x. Then I'm going to divide by 3, divide by 3, divide by 3. Y equals 8/3 plus 5/3x. All right, so the slope for this one is 5/3. And again, both of these are positive. So let me actually put the positive sign there. This is a positive 3/5. This is a positive 5/3. All right, so again, if we look at this, this is kind of like A, where yes, the fractions were flipped, 2/3, 3/2. Here again, our fractions are flipped. We have a 3/5 and we have a 5/3, but both of these are positive, which means our signs were not flipped, and since our signs were not flipped, this is going to be another neither. We can't say it's perpendicular because the signs are the same. And that kind of makes sense. If you think about perpendicular lines, you know, one's going to be going up, one's going to be going down, so there's always going to be one that's positive, and there's going to be one that's negative. So in this case, since they're both positive, they're not going to be perpendicular lines. Okay, so I hope this was helpful. Have a good day.